This video was part of a recorded tutoring session. I'm making it available because I know it will be of help to some. My name is Daniel. I understand how figuring out concepts or problems in math or physics can be tough. Trust me, help from a tutor can make a huge difference. At the end of this video, there will be information on how you can contact me for questions or tutoring requests in math or physics. The question that we solve in this particular video is about projectile motion, and it says that a ball is thrown horizontally from a building 18 meters high with a speed of 2 meters per second. How far from the base of the building does the ball hit the ground? We're going to start by saying, as you rightly said, how far from the base of the building? That's a question of that length that we're being asked for is another way of saying what's the delta x. A diagram would also help here. Thrown horizontally from a building. This is the building. Ball is thrown horizontally. So the ball is not going to continue going horizontal. It's going to somehow. It's going to start out horizontal, but it's going to start to fall down. So that what we're being asked for is this, from the base of the building, this length. That's what we're looking for, and that's what we said it's the delta x. Actually, I'm just going to call it L. But we know that it's delta x, and that delta x. Remember that in a projectile motion, the horizontal velocity stays the same. So it's just going to be Vx times time.
Yes.
And the ball was thrown horizontally with a speed of 2 meters per second. That tells that the V was 2 meters per second. But because it was horizontally, whenever that's the case, remember that whenever in a projectile motion, whenever the initial velocity is all horizontal, that means that the Vx is all V, right? So that means the Vx is going to be 2 meters per second here. But what about the V naught y? Thrown horizontally.
0?
0, good. So if we go back to this, that means we pretty much have this. We only need to find the time. So the real question is, what's the time?
2?
We don't have the time. But to find the time, we have to analyze the y motion. So I'm going
Yeah,
to
I
make
thought 2 meters. Oh, never mind.
So to find the time, in other words, the time it takes to come here, that's the same as the time it takes for something. So here's where it gets interesting. To look at the time, you forget about the projectile. You just think about the vertical. The vertical is just as if a ball dropped down. In the vertical motion, as far as we're concerned, it's just as if a ball dropped down by, actually I'm going to project it, by a displacement of 18 meters, that's all. But because the ball dropped down, that displacement would it be positive or negative?
Negative.
Negative, so delta y of negative 18 meters. G.
We had here 18.
That's the height of the building, right?
Oh, yes.
So we're pretty much trying to see what happens as the ball goes from the top of the building to the ground. G is 9.8 meter per second squared. And V naught y equal to 0. So we have three things that we know, one unknown, we can use a kinematic equation. Whenever you have three things that are known and one unknown, you can use one of these three equations. So which of the three equations are we going to use?
Vy equals V naught Y minus GT.
So if we use the Vy, we're going to be stuck because we'll be having to mess around with Vy, and our question doesn't need that. We don't need Vy, and we're not giving Vy. So think of the one that does not have Vy in it. It seems like we do not have.
Yeah, I all have it.
Look at the second one though. So 1, 2, 3.
Yes.
So what does the second equation say?
The change in Y?
Yeah, equal to
V naught Y times time plus 1/2 GT.
GT squared.
But we don't have change in Y. Oh yeah, we did. Never mind.
Yeah, so that's the one we can use. So also, just to make sure we're on the same page, if you've already taken A to be negative G, then this would have a negative in it. It would be negative half GT squared. But if you didn't make that assumption, just make sure the signs come out right, and you would know your numbers would turn out wrong if you make a mistake with the sign. So we're going to use that delta Y equal to V naught YT minus half GT squared. Delta Y. So we're trying to solve for time. By the way, because V naught Y is what? 0.
Yeah.
So that means this first part of the first term here is going away. So we're left with delta Y equal to negative half GT squared. And we're trying to solve for time. So if we do some math gymnastics, multiply both sides by 2, divide by negative G, and you can check this by yourself. If you don't like this step, let me know. But I would say that 2 delta Y divided by negative G square root equal to time. Do you agree with that?
Yes.
Yeah. 2 delta Y divided by negative G equal to time, square root. And that's it. It's always good to do things like this before you bring in numbers, because that way you only you minimize the keystrokes on the calculator, and you also reduce the chances of error when you solve the formula for the variable before you plug in numbers. Does that make sense? So this just becomes 2 negative 18 divided by negative 9.8. I'm leaving out the units because I know it's going to come out right. If it's a more complicated question, it's sometimes advisable to put out units. Sometimes the instructors will say omitting units. I don't. Just make sure that you know what your final unit should be. And we know our final unit here should be in seconds. So that should be about, I'm thinking something less than 2 seconds.
1.91.
Yeah, that sounds right to me. 1.91 seconds. But is that all? Is that what we're looking for? Is that the
No.
So what do we now need to do?
Now we need to plug time into change in x equals Vx time.
Good. That's all we need to do now. So we go back to, what made us go through all this to find the time. And so now that we know that the Vx, now that we know time, we just say 2 meters per second times the time we have, which is our 1.91 seconds. And that will give us something in meters.
Yes.
That should be about...
I got 3.83 meters.
And the answer, you need you to put the answer in two significant figures. So 3.8 should be good, isn't it?
Yes.
So yeah, that should be about 3.8 meters in two significant figures. Does this make sense? Do
Yes.
you want to try to plug it in? Or you want to do that later?
I'll do that later.
Okay. So do you have any questions?
No.
So you see that it's not that difficult. You just have to be very familiar with the equations and where they go. But you're going to be able to do it because I can see you're asking good questions. Continue to ask good questions. I trust that the physics problem that we just solved made some concepts and steps more clear to you. For more help in physics or math, or for specific questions or problem sets that you may be working through, I'm very happy to assist you. And here is how you can contact me. I've had more than 10 years of working with students at all levels in all kinds of physics and math. In math, I've worked with students in Algebra 1, Geometry, Algebra 2, Integrated Math, Statistics, Pre-Calculus, and Calculus. In physics, I've had the joy of working with many students in high school physics, AP physics, college physics, and university physics. As you can see, the rates are very affordable. I hope, and I really do hope, that we get to have some math or physics fun together.